Hello everybody and welcome to today's class. Today we still continue with topic 1.7, which as you remember is properties of rational exponents and logarithms. Okay, today we will deal with part sorry about this. There you go. Okay, today we will continue with part number 4, which is solution to exponential equations. Okay, and before we start, I need you to have the following by your side for quick reference. Okay, I need 5 things from you. Number 1, you're gonna have to have the properties of logarithms that we already proved. That is, for example, these ones. The logarithm base a of a equals 1. That was the first one. The second one was logarithm base a of 1 is 0, and so on up until number 7, which was logarithm base a of x equals logarithm base b of x over logarithm base b of I. I'm gonna give you 1 minute to have this by your side on a different sheet of paper or notebook, because you're gonna be consulting this over and over today. So I give you 1 minute to get ready. Okay, very well. That is the first thing that you need to have by your side right now. The second thing that I need from you is to have ready your calculator with you. And please, preferably, use some Casio or something like that. Do not use yet the TI. Number 3, find the key log in your calculator. Just find it. Locate this key. Number 4, we need to establish the following. In mathematics, usually when we have a logarithm base 10 of a number x, usually, and by usually I mean 99% of the time, this is written as logarithm of x. That is, we can ignore the base. This is exactly this. So when you want to say logarithm base 10 of x, you can simply say log of x. These things are exactly the same. And this is for convenience purposes. Okay? It's the same idea behind, for example, when we have a number to the 1, we never write the 1, right? These two things are the same. So these two things work in the same way that this works. And number 5, we're gonna state a very simple fact, which is this: if two numbers are the same, then the logarithm base a of the first number has to be equal to the logarithm base a of the second number, which is extremely simple to understand. Okay, so these are the 5 things that I need from you to enter this part 4 of the topic 1.7. Okay, so let's first do 3 quick experiments. The first one is, I want you to calculate with the calculator the logarithm of 10. Try to do it quickly. If you got 1, you were correct. And remember, this is the same as writing logarithm base 10 of 10 equals 1. Okay? The second experiment is calculate also with the calculator the logarithm of 1/2. Do it. If you wrote minus 0.301, you were correct. And finally, the third experiment, calculate the logarithm of 5 over log of 9. Perform this division with the calculator. If you wrote 0.73, you were correct. Okay, so with all of these things in mind, let's enter to the part 4, which is exponential equations. The solution to exponential equations. Okay, so I'm gonna solve with you 4 equations, and I'm gonna take a lot of time for you to copy after me, or in other words, for you to follow my explanations. Here we go. The first equation will be 4 to the y minus 1 equals 19. So far we were not able to calculate this type of equations, okay? But now with the knowledge of these logarithms and the knowledge of rational exponents, we can solve now this type of equations. How can we solve this equation? We can do the following. First, I'm going to simplify a little. I'm going to add 1. So we get this. Next, I'm going to do the following. Since this number is equal to this number, I'm going to take the log of both numbers. That is, if this number is the same as this number, then the logarithm of that number is equal to the logarithm of the other number. And remember, this is logarithm base 10, but we usually don't write it down. Perfect. Now, I need you to look at the list of properties, and I need you to look at property number 6, the one that says this: logarithm base a of x to the n is equal to n times logarithm base a of x. Okay, this was the property number 6. I'm going to use this property. For example, in here we have logarithm of 4 to the y. And if I apply this property, this will be the same as y times the log of 4 equals the log of 20. I will give you some time to understand why, by using this fact or this property, I can come up with this new statement. Very well. Next, since we are trying to look for y or to find y, all I need to do next is isolate y. Obviously, by dividing both sides over the log of 4. We continue on this side. And then all we have to do is, with the calculator, calculate log of 20 and divide it over log of 4. Do it. Those numbers are 1.30 and 0.60 approximately. Okay, you need to understand that these numbers are not exact. These are just approximations of these two numbers. So basically, in the end, y is equal to 2.16. Or more properly speaking, we should say that y is approximately equal to 2.16. This is the answer to the equation, to this equation. Now I want you to prove, or not prove, to make sure that this is in fact the solution to this equation. All you have to do is raise 4 to the 2.16, subtract 1, and you should get something very close to 19. Please confirm. Okay, perfect. I hope you could have done that. So that was the first equation. Let's go to the next. Equation number 2. 8 raised to the 4x plus 2 plus 3 equals 10. Very well. How do we start? We simplify a little in this way, right? Okay. And next, I'm gonna also apply the logarithm in both sides. If this number is the same as this number, then the log of the first number will be the same as the log of the second number. We continue. Again, by using the sixth property, which is this one, logarithm base a of x to the n equals n times the logarithm of x. Now I can represent all of this in this way. I'm going to lower this exponent in this place, like so. Make sure to understand why this is the same as this according to my property number 6. I'm going to give you some time. Very well. Then we can continue. Now, I'm going to divide both sides of this equation over log of 8. And I will get the following. Right? We continue on this side. Okay, so now let's calculate in the calculator the log of 7 divided over the log of 8. Do it on your own. The answer will be 0.93. And then the rest is very easy. This is just a linear equation and we solve for x. I give you some time to resolve this equation. Do it. And the result you will find in the end will be negative 0.267. So this is the solution to this equation. So you can see how now, with your knowledge of logarithms, equations like this, which were more complex than the ones you knew before, now you can solve them. Let's go to equation number 3. The equation number 3 will be 3 times 10 to the 2w equals 33. Okay, how do we start? We simplify a little by dividing both sides of this equation over 3. And you will get this. Then, since this number is the same as this number, then the log of the first number will be the same as log of the second number. Then, again, one more time, I'm going to write it down, so just in case you don't have them there for quick reference. The sixth property says logarithm base a of a number raised to another exponent is the exponent times the logarithm of the number, which is what we have here. So this will be the same as 2w times the logarithm of 10 equals log of 11. Now let's divide both sides over log of 10. And then let's calculate this division. Do it. You should get 1.041. And finally, we just divide over 2 in both sides, and we get that w equals 0.52. And this is the solution to this equation. equation number 4. This one is a little more complex. So let's write 1/3 raised to the x equals 9 raised to the x plus 1. Okay, the idea will be exactly the same as the ones before. So, how do we start? I'm going to take the log of both numbers. 1/3 to the x, this is the log of this number, will be equal to the log of the other number. Then, again, by applying the sixth property, which I hope you have memorized already, this will be the same as x times the logarithm of 1/3 equals x plus 1 times the logarithm of 9. Make sure that you understand why this is the same as this and this is the same as this according to property number 6. Fine. We can continue in this way. I'm going to divide both sides over log of 1/3. And now we continue over here. Now I'm going to divide again both sides of this new equation over x plus 1 in order to have this. These are very simple algebraic steps and you should be very confident about what I'm doing. Okay, so what do you think is the next step? Calculating this division with the calculator. Do it. If you got -2, you were correct. Okay, so now you can see that by applying properties of logarithms, we have reduced this equation, the principal equation or the original equation, into an equivalent equation which doesn't have any logarithms. Okay, so that's why this is the properties of the logarithms are very useful. Okay, now what do we do next? Very simply, we multiply both sides over x plus 1 . I'm sorry, I said over. I should have said by. We multiply both sides by x plus 1. There you go. And then we solve this very simple equation. I'm going to give you some time to solve it. And the final solution will be x equals minus 2/3. So this is my solution to this equation. And just as a final confirmation, try to make sure of that. Try to make sure that this number is the solution to this equation. In other words, raise 1/3 to the minus 2/3, and that should be equal or approximately equal to 9 raised to the minus 2/3 plus 1. Make sure that you make sure of this. Okay, I hope you have confirmed that this is in fact very approximate to this, and those are the 4 equations that I wanted to present to you. Later, I will send you an activity with more of this type of equations. Thank you.